Hi everyone, welcome to the new video. Let's solve an equation for the value of x in which we are given that x to the exponent x is equal to x squared. Now, in order to solve this equation, we state some specification of the equation and the limitations of the solution. So if you notice, the equation is of the form x to the exponent x equals to x squared. On the left side, we have x to the exponent x, which is an exponential function. And on the right hand side, we have x squared, which is nothing but an algebraic equation. So basically, we are given an equation which is coupled with an exponential function and the algebraic functions. If you notice further that on the right side, we have x squared. In this function, for any value of x, we will get a positive result of x squared. For example, if even x is negative, then we square it and it becomes positive. So the left side must also be positive because the right side is positive. And the left side is an exponential function which is x to the exponent x. And this should be positive too. But unfortunately, this is not positive for all values of x because if x is negative, then the solution of x to the exponent x is a complex number r involving the iota. So we restrict ourselves for the left hand side to be positive for the only positive values of x. Another restriction to the solution is that if we insert x equals to 0, notice on the right side, so we have 0 to the exponent 2, that is 0 squared. But on the left side, we notice that it is 0 to the exponent 0. And 0 to the exponent 0 is undefined. So overall, we have two restrictions on the solution, that the solution is only positive values of x, and other one is that x is never 0. Thus, we will solve the above equation for the positive values of x, and restricting x should not be equal to 0. Now, let's move on to the original equation that is given as x to the exponent x equals to x to the exponent 2, that is x squared. So, the first step towards the solution is that we collect terms involving x on the one side. For this, dividing both sides of the equation by x squared, we have x to the exponent x divided by x squared, and the right side is x squared divided by x squared. X squared gets cancelled with itself on the right side, and this will be equal to 1. So the left hand side, because in case of division, bases are same, so we will subtract the powers. So we have x to the exponent x minus 2 equals to 1. Now taking log of both sides so that we bring x minus 2, which is an exponent, into the base by taking log. So we have log of x to the exponent x minus 2 equals to log of 1. Since we know among the properties of logarithm that log of a to the exponent b is equal to b times log of a. So utilizing this property in the equation, we will find that x minus 2 times log of x is equal to 0 because log of 1 is equal to 0. Since product on the left is equal to 0, so either of them must be 0. So we decide either x minus 2 is equal to 0 or log of x equals to 0. If x minus 2 equals to 0, then x must be equal to 2. That is, value of x is 2. So one of the solution of the above equation is that x is equal to 2, which is obviously a positive and non-zero. Similarly, for the other solution, we seek the log x equals to 0, and we know that log of 1 is also 0. So the arguments of both must be same because of their same value. Thus, x is equals to 1 as well. So the other solution is that x equals to 1. Similarly, looking in the graph, we see that we have two common solutions are intersecting points of the both graphs 1 and 2. Say the graph is x squared, that is in yellow line, and the other one is that is in the blue line is x to the exponent 2. So thus it is evident from the graph as well that there are two solutions of this graph. Thanks for watching this video. Hope to see you in the next one.